Here are the correct answers to the quiz. Let's take a look. See what we come up with. Okay? On the first one, it's slope, so I had to write the slope formula there, and you have to know the difference between the first and the second point. Doesn't matter which order. I called this one the second one, that one the first one. So I did, if you go in the other order, it works the same. I get 6 minus 3 over 1 minus negative 2. Now, if you go in the opposite order, you get negative 3 over negative 2. But when you divide by a negative, it turns into a positive. So either way, it comes out to be positive 3 over 2. Number 2. What's the equation of the line parallel to this one with the same y-intercept as the other one? So that means since it's parallel, I have to look for the slope here. Y equals mx plus b. The slope is m. It's how you move. It's in front of the x. In this case, the slope is 2. And b is the number at the end because they're in y equals form already. And I need the same y-intercept as this guy, so the b has to be 3. So I get y equals 2x plus 3. Okay? What are the slope and y-intercept of this line? The problem is the way the line is set up, it doesn't say y equals. So I have to get the y all by itself, which means in this case I need to divide by the 3, which I did. The slope is 1/3, the y-intercept is negative 3. And then it wants me to graph that line. So I begin at negative 3, and I go up 1 over 3, up 1 over 3, and draw my line. All right. Any problems? No. Okay. Now, these are pretty much the same as yesterday. This would work out to be negative 9 for number 1. Which of the two graphs is a function? You tell me. On your paper, which one? B is a function?
No.
Can I see your paper, Jocelyn?
B is a function. A is.
A is not, B is. The reason is a vertical line test, folks. Which of these is a function? A is not,
B is.
B is. A is not because of the 2 3's.
Oh.
Is this true always, sometimes, or never? Similar triangles are exactly the same size and shape. Sometimes. If you have similar triangles means, or similar figures, Davis, means that you have same shape, sides proportional. If the figures are the same exact size, the proportion is 1 to 1. Everything is equal. 2 triangles are similar. This one I need to do on the board. Okay. 2 triangles are similar. As soon as I read that triangles are similar, in my mind, I'm thinking, little is too big, as little is too big, little is too big, as little is too big. I want to be so annoying with that song. I want it to be stuck in your head like, Frere Jacques, Frere Jacques. Now, which is right up there with John Jacob Jingleheimer Schmidt.
I don't know that one.
His name is my name too. Whenever he's around. Na, 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 na. John Jacob Jingleheimer Schmidt. Na, 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 na. All right. Now, little is too big, as little is too big. Now, it's more than just being annoying. It also tells us where to put the numbers. And that's very important. Ready? Sides in first triangle are 7, 9, and 11. Smallest side of a similar triangle, the other one is 21. So wouldn't the smallest one match up with the 7?
Yeah.
Because the 7 is smallest? Okay. So little 7 is to big 21. Alright. Now, it starts talking about perimeter. What's the perimeter of the little triangle? What is the perimeter of the little triangle? Hey, what's perimeter mean, everybody?
Outside.
Add up both sides. Good. Let's do it this way. What's 11 and 9? 11 and 9, 20. Plus 7, 27. And then x. Cross multiply. 7 times x is 7x. 21 times 27. 270, 540, 567.
So is the smallest number always on top, right?
Well, if you do little is to big, little is to big. And it's very, very careful, Matt. It's very important, and I'm really thankful you asked that question. It's extremely important you realize it's not just about the smallest number. It's about smaller triangle, bigger triangle, and pairing up the parts, okay?
Because I
So-
know what to do, it's just that's what he was getting.
Well, yeah, if you set up the proportion, then it's easy. So the whole game is learning how to set that proportion up.
It's a blue.
So,
81.
I'm gonna get, yeah, that goes into there 81 times. And that's the correct answer, okay? Are there any questions about the do it? Okay, so let's go forward then into today's lesson. You see on this sheet, there's the homework answers from yesterday. You can always check that out a little later on. Now, let's graph the following. So everybody graph this triangle right here on your paper. Just so you know, do you have a line down the middle of yours?
No, I was just like George.
So what you want to do is you want to put a line down the middle. Sometimes it comes out, sometimes it doesn't. And a line down the middle. Go ahead. Graph that triangle. I'll give you less than a minute to do that.
We got a triangle.
Okay, so first point is 0, 0. The next point is 4, 3. And the next point is 4, 0. So there is my triangle. Okay? And then it says, extend the lines to the following points. Ready? I'm a little off the graph there, but that's 8, 0. And here's 8, 6. So now I have a blue triangle and I have a red triangle. Which one's bigger? How many times bigger is the blue triangle?
Twice.
How did you get twice?
It's
Because
just
the
little
small
boy.
one just fits in, I don't know.
Every time.
Jocelyn, how'd you get twice?
Me?
I thought Jocelyn said it. Was it you, Alex, who said
Yeah,
it? How'd you get twice as big?
I just did it visually.
Yeah, I know, it just
Visually?
looks like
Yeah.
it
Okay.
fits in twice.
How was it visual? Because I like that
I
answer.
know. I know.
The small triangle
Not many.
fits perfectly like in the middle of the triangle.
Okay, the red line goes right to the middle of the blue line. That's a great observation. Manny?
With your x-axis, because you can divide 8 into 2. 8
Ah.
squared.
Look, check this out. Ready?
I think mine was 1.5.
How long is this one?
I have
4.
4.
How long is that?
8.
8.
Up.
Little is to big. 4 is to 8. Now. How long is this guy? 6.
6.
How long is this guy? 3. Let's check and see if that's true. What's 8 times 3?
24.
24.
What's 4 times 6?
24.
Yeah, so that works. So little is to big is little is to big. Not only works when you draw pictures, it also works on graphs, as long as the triangles are similar. Okay, now, we're going to start getting into the idea of transformations. The idea that we take a triangle, or a square, or a rectangle, or a trapezoid, or any other figure, quadrilateral, and we change their shapes. Sometimes we move where they are. Sometimes we make them bigger or smaller. Sometimes we rotate them. Sometimes we flip them. Sometimes we slide them, okay? So that's what we're working on right now. This guy here would be what we call a dilation. Did you ever hear of your pupils getting dilated?
Yeah.
Yes.
It's when your eyeballs, like your pupils, open up extra wide and they let more light in. You may have felt it, like you ever go outside in the bright sun in the snow and you go from inside the house and you're like, oh!
Yeah.
All right? Now, that's an example of your pupils dilating. To dilate means to get big, okay? Or bigger or smaller, but you change size every time. The red one clearly got twice as big to become the blue one. Okay, so. Let's do littlest to big on this guy again. Go ahead. Find the length of n.
Find N.
Now, there's a couple of different ways to understand it. One way is to go back to what I feel is the trustworthy fallback technique. The thing that always seems to work. And that is, little is to big, as little is to big, little is to big, as little is to big. Somehow I think Mr. Altalia can do a better job at this than I can. How many people here think Mr. Altalia can do better than me?
Mr. Ty has the flu.
I know.
Exactly.
I know. I'm not worried about her having the flu. Adults get the flu, you get past it. It's the little kid I worry about.
I know, that's what I'm worried about.
Okay, so, little is to big, as little
Wow.
is to big. It's the British approach here.
Wow.
N is to 27. All right, Doctor. Now, N is to 27. Now, what's the other side look like?
11 is to 33.
11 is to 33. Good. Now, if you want to avoid multiplying big numbers, you can always reduce these fractions if it's possible. What is 11 over 33 reduced to?
3.
Careful, 1/3.
What?
1/3.
Oh.
3 would be if the 33 was in the top, right?
Oh, yeah, yeah.
So then I cross multiply and I get 3n equals 81. Divide by 3. Hold it.
Okay, so root of
3n equals 27, I'm sorry.
Yeah, I was gonna say what?
Right? 3 times n is 3n, 27 times 1 is 27.
Nine.
Divided by 3, n equals 9. Now, there's this very fancy term. Sometimes educated people like to sound really, really smart.
Okay, what's the word?
See, I happen to like people that are really, really smart and don't necessarily feel they need to sound really, really smart.
Not me.
I like smart. Smart is big. I love smart. Smart is really, really good. I respect smart. But I don't like people who walk around like, I am, the perspicacity of the particular situation causes me to look for the vicissitudes in our protoplasmic being.
What?
Right, exactly. Now, I happen to be able to understand that. I remember going to
What does
my
that
doctor.
mean in English?
Yeah, don't worry. I remember going to my doctor, and when my knees were getting all their surgeries, I remember going in high school to just get a checkup. And my mom brought me into the city, so I go into the city, and I'm sitting there talking to my doctor. I will never, ever, ever forget, the doctor would have to talk to me, and I would have to turn around and talk to my mother. I was translating English to my mother. Right? She could not understand the level at which he spoke. So, if this is going to sound fancy. It's going to sound arrogant. The ratio of similitude.
Okay.
You got to say that like you're a snotty British guy.
Similarity.
Everybody go, ratio of similitude. There you go. Frankie does it well. Go ahead, Frankie. Say it again.
I said it.
Yes, you were perfect.
The ratio submitted.
There we go. Now, the ratio of similitude would be what I'm multiplying by. what did I multiply by to go from the little one to the big one? So I'd say the ratio is 1 to 3, because it's getting 3 times as big. Does that make sense, everybody?
Yeah.
All right? Sometimes it'll say, what is the scale factor? That's kind of like more normal English. And when they say, what is the scale factor, they're saying, what are you multiplying by? And what am I multiplying by, everybody?
9.
What am I multiplying by?
9.
9. You're telling me 11 times 9 is 33.
No, it's 99.
Right, so it's not 3, I'm sorry, it's not 9, it's 3. Yes?
What determines like where the end fraction is going to be? Like
Oh, where
if
the
it's
end
gonna be
goes?
on the-
It
yeah.
could go any place, as long as it's consistent.
Yeah,
So
but-
I could put the end over here.
Oh,
And I got news for you. If you really want to try to impose on my copyright on this music, you could go, biggest to little,
Wait,
biggest
is
to little.
the end always on top?
If it's a little, but what if the end's on the big side? Right? What if I put the end over here?
Because I put the end on the bottom.
Oh,
And what if I put the 9 here and the end where the 27 goes? Then the end would go in the big place, because it's part of the big triangle.
I get it.
When I say little is to big is little is to big, it all depends on which triangle you're
So
talking
if the
about.
end is on the big triangle,
It goes in a big place.
Oh, so it goes on the bottom.
What?
Depending on which
Okay.
fraction, like you could do the 11 and the 33 on the left side or on the right side, and the end goes in the opposite side.
What?
Okay? Ready?
I finally just do that.
Thank you for settling down. Figure out X. Find the length of X. All right, hold on, give everybody a chance to catch up. Or you could think of the ratio of symmetry.
So on a test or quiz, do you have to show work out?
Sometimes, a lot of times no. If it's like one of these multiple choice questions or part 1, no. If it's like one of these extended response, like this you would have to show.
What? Wait.
I got 18 over 4.
Yeah.
I don't think so. Oh, 18 over 4 reduces to it, yeah. Reduce that fraction.
But
Would be the right answer
Oh, the
when
wire
you
line?
reduce. Okay, ready? Keep going.
Oh, wait.
Ready? Little is to big, as little is to big. Now, Matt, to address your question before, is this X going to go in the place of a little or in the place of a big?
little.
That's right. What was that, like a mixed answer? A little.
No, I was
Yes,
trying
they
to
will
think
go
of
in a
my
little.
I was thinking.
So I like, when I set this up, again, the order doesn't matter. What matters is consistency. I tend to look for the X first. So X pairs up with what?
9.
9. So X is to 9 as what to what?
2 to 4.
2 to 4, good. Cross multiply. 4x equals 18. Divide by 4. Reduce it, I get 9 over 2. Can you guys tell me what 9 over 2 equals as a mixed number?
A 9 over 2 is 4.5.
4.5, very good.
Oh, I got 4.
Now, let's talk, hey, let's talk here, ready? Isn't 2 half of 4?
Yeah.
And isn't 4 and a half half of 9?
Yeah.
So that ratio of similitude that it's going to be half as big. Okay, now, hey, your job tonight is to keep setting up these proportions and doing little is to big. Tomorrow, we're gonna talk about reflections. The day after that, we're gonna talk a little bit more reflections and then transformations and then rotations and then dilations, and then we have another series of tests coming up. Excuse me, hey, in seats. Back. No, get on the way out the door. Chris, have a seat. Kenneth, squat, pull your pants up, unless you'd like me to do it for you. I definitely wouldn't want me pulling your pants up. It's been known to frequently result in wedges. The best was years ago, Mr. Friend and I fought across the hall from each other. And kids would walk around the corner, and you'd see them pulling their pants up really, really high like Urkel, because they knew if they got near us, we would each grab one belt loop, pick them up, carry them down the hall, and they go,
Do you still do that?
no, because A, I don't have Coach Fren around anymore, and B, we used to be on the second floor. You know where the language rooms are on the second floor
Yeah,
down
yeah.
there? That's where we used to be, so they would come around the library,
Yeah?
and they'd come around that hall and they'd start pulling their pants up all the time. Yes, just like that. Exactly what they do.
Yeah, like.
You got, the times have changed. I had this teacher when I was in first grade named Mrs. Palmer. Mrs. Palmer was a very large woman who came from the Bronx. She used to be in the military. She used to, oh no, Durante was nothing compared to her.
Really?
Oh, very large, very intimidating, and she'd hit you with a ruler every time you got a question wrong.
Ruler.
And you walk down the hall with a book on your head, and if the book fell, you got hit.
I wouldn't have, literally, I wouldn't have said anything. I
Right?
wouldn't have answered any questions. I literally.
No, she looked at your paper, and you had to have your hand on the desk. Very. 100% serious. Great teacher. Your parents loved her.
How many times have you
Did I get hit? Plenty. But my parents think she's the reason I was a great student. My teacher the next year was really pretty. I thought.
Really pretty?
Yeah, there we go. That's what did it.